So in the second part of the project, we're going to add a potentiometer and use it to control the rate at which the LED blinks. Now let's talk a little bit about the potentiometer, because we're going to be using these in quite a few of the projects. A potentiometer is basically a strip of resistive material, and it has contacts on both sides. And typically what you do is you connect one side to some kind of a voltage. 5 volts is a pretty common voltage, and the other side to ground, or 0 volts. Then there's a third pin that's a sliding contact, and it's symbolized as an arrow. So this is able to slide up and down the material. When you slide up all the way to this end, you get the full 5 volts out of the potentiometer. When you slide it all the way down to the bottom, you get 0 volts. And if you're somewhere in the middle, like this is about, say, 2/5 of the way up, you get, say, 2 volts, 2.5, whatever. So it gives you a way of producing a varying voltage, and then you can use that varying voltage in your program to vary some other kind of variable. Now the potentiometer we're using is a rotational pot, and most pots are rotational, although they do have linear. And all that means is that this strip of material goes around in a circle, and the sliding contact is on a pivot in the middle. And so as you turn the pot, that sliding contact, here's one side of the pot, here's the other side. So you would put 5 volts to this side and ground to this side, and then the third pin comes out in the middle, and this would be your analog output, or the voltage, I should say, analog voltage. So the symbol that you see on the schematic is a resistor with a sliding contact, 3 pins. So the actual potentiometer looks like this. It's got 3 pins, and the middle pin is the sliding variable pin, and the 2 end pins are the ones on the sides. So let's connect the potentiometer. I'm going to unplug the Arduino, so I'm not doing any circuit changes while the circuit is live. And so you take the potentiometer and plug it in so that the pins are on 3 separate connection points. Now I'm going to need 5 volts, as you can see in the schematic. I need 5 volts to connect to one side of the pot, so that's going to come from the Arduino. There's a 5 volt pin right next to the ground pin, and I could actually go directly to the pot, but just because this is showing we're going to be doing this a lot in the future, I'm going to plug it into the breadboard bus line that's marked with the red line. So that's going to be my 5 volt line. This is my 0 volt line. So now I just have to connect the potentiometer. One of those end pins goes to 5 volts and the other one goes to ground. Now if you have a wire kit like this, or maybe a smaller version with the pre-cut wires, those are very handy because they're cut to exactly the right length. If not, you can certainly use some of the jumpers that you've got, but I like these because they make very short direct connections. So I'm going to connect one of these to 5 volts and the other one to ground. So those are the 2 ends of the pot, 2 end pins, and that middle pin that's waiting is going to go to the analog input, and we're just going to go right into analog input 0. All right, and that's it. So we connect the Arduino back up. Now back on the program, we need to make a couple of changes. First of all, if you look at the schematic, we now have 2 pins involved, not just the output to the LED, but now we have an analog input. Now, so I need to define that pin, int, and I'm going to call it pot pin. Pot is short for potentiometer. And that's equal to pin 0. Now when it's an analog pin, this is optional, but it's a good practice to use the letter A, 0, to indicate that it's one of the analog inputs. You could just put 0, but I find it better with programming to always indicate A when you're dealing with an analog, so you can tell when you look at it. And so I'll do a similar comment here. Give the name pot pin to analog input. And another change we have to make is that in order to be able to use the value from the pot, we have to read the pin value and store it into a variable location. So we have to create a variable. So it's going to be another integer, and I'm going to call this pot value, which just means the value coming from the pot. And the command to read the analog input is analog read, and then we have to tell it what pin we're reading, and it's pot pin, the pin that we just defined. Now you may remember from the lecture that the analog input of the Arduino can accept voltages between 0 and 5 volts, any voltage, and it converts that value into a binary number, a 10-bit binary number, which goes from 0 to 1023. So what the pot is going to read is a value between 0 and 1023. That represents a voltage. Like the voltage, the value 1023 represents 5 volts, 0 represents 0, and all the values in between represent all the voltages in between as well. So we're going to use that pot value as our new time unit. So in the first part we had the time unit fixed at 200 milliseconds. Now it's going to be varied based on how we dial the pot. So I'm just going to replace the hard-coded number 200 with pot value. Okay, so now what do we do about this? We want it to be 3 times the pot value. Well, there's some mathematical operators that you can use in Arduino programming. And so the operator for multiplication is the asterisk. So if I want to say pot value times 3, I do pot value asterisk 3. So that will give me 3 times the potentiometer value. And then the last delay, which is 7 times the value, I just changed that times 3 to a times 7. Now that pot value, as I mentioned, is going to go anywhere from 0, which would be 0 milliseconds, which would be infinitely fast, to 1023, which is a little over 1000 milliseconds. So if we dial it to 1023, it's going to be really slow. The Morse code pattern is going to go very slowly. If we go down close to 0, it's going to be so fast we won't even be able to see it. But somewhere in between, we'll be able to have a reasonable rate of blinking. Okay, I'm going to upload this to the Arduino. Okay, now you can see I must have the pot dialed pretty far over. Now one thing is, you notice that in our program it only reads the value at the beginning of the pattern. Once it starts the pattern, if you change the value, it doesn't make any difference, because it'll read it once per cycle. So if it's going very slowly, it's going to take a little while to complete the pattern before it reads your new value. Now what I just did, you see how the LED is almost on permanently? That just means it's going extremely fast. That's what happens when you dial it down close to 0. it hardly has any delay at all, and it just kind of looks like it's on the whole time. But if I get somewhere in between, there's my dot dot dash dot dot dash dot dot dash. Okay, so there's the number, the letter. And I can change the blink rate. I can make it slower. So I hope you enjoyed that demo, and good luck with the lab.